Good morning all. Today I'm going to play with Thermodynamics. Well, a Peltier element. And you too can play with Peltier elements for, well, very little money. This one cost me $1.86 on eBay. They're really cheap. So this is the one I bought on eBay. It's a Tech 1-12706 heatsink thermoelectric cooler, cooling Peltier, plate module 12 volts, 60 watts. Now this was $1.86, free shipping, and it came from Alice 110 1983. Now the Tech 1-12706 is probably the most commonly available Peltier element on eBay, but what does this mean, Tech 1-12706? Well, let's take a look. And for this, I've gone to owenversteeg.com, and he's got a nice identification here. This actually is duplicated at the bottom of the Wikipedia page on the Peltier element. Now, it seems to appear that TE stands for either thermoelectric or thermoelement. The C apparently stands for the size. C is a standard size, S is a small size. 1 is that it's one element or one stage. We'll have a look at that in a moment. 127 is the number of couples, or the number of couple pairs, because they're in PN junctions. So there are 127 pairs in this particular element. And this one says 09, but mine says 06. And that's the current. So my element is a 6 amp Peltier. Right, let's play. Now to play with this thing, or to start playing with it, I'm simply going to connect it to an Eneloop nickel metal hydride rechargeable cell. I could also use an alkaline, but why waste the energy in an alkaline when you can recharge a nickel metal hydride? So what I'm going to do is just connect this to the positive and negative terminals, and the Peltier element will heat up on one side and cool down on the other. Now you can feel that with your fingers, but actually your lips are a lot more sensitive. So warning, I'm now going to switch to the front-facing camera. So the best way to feel what this thing does is to stick it in your mouth and then connect the battery to it. So negative, positive. Now the reason for shoving this in your mouth is because, of course, your lips are more sensitive than your fingers, so you're going to get more of an effect. I don't think there are any nasty chemicals on here. It's got ceramic plates, there's some silicon sealant around the outside. Even the chemical inside I don't think is particularly harmful. I did look up the toxicity of beryllium telluride or whatever's in here. It didn't seem to be that bad. So when you power this thing up with a single 1.2 volt cell, you'll notice that this thing starts to pump heat. So on mine, this surface that has the printing on it has gone cold. The other surface has gone warm. Now it's not a very aggressive effect because I'm only putting a small voltage and therefore a fairly small current through this thing. But you don't want to be putting the full 6 amps through this without any heat sinks or a metal on this device, because it will get extremely hot on the hot side and probably destroy itself within a few seconds. So the Peltier element is a heat pump. This device is now pumping heat from the, well, now cold side, which is this side, to the warm side, and I can feel the difference there between cold and warm. So a question that often comes up is, how cold does the cold side get? Well, of course, it depends on so many factors. It's not going to get particularly cold with a 1.2 volt cell. Also, it depends how efficiently you remove heat from the hot side. Because if I'm pumping heat from this cold side to this hot side and I let the hot side get very hot, heat will actually conduct back through the elements back to the cold side. So the efficiency is very poor if we're not heat sinking the hot side. Let's try an experiment on this. Right, I've been holding the Peltier on this battery for a little while. Let's try with this thermometer. I've got to fire the laser dot slightly above the Peltier because of parallax. So I'm getting about 16.5 on the Peltier. On the green mat it's more like 20. So back to the Peltier, 16.3. Let's try the hot side now. Just flip it over. And that's showing the matte is 20-ish and the Peltier is showing 26.7. Now the cold side doesn't seem to be getting any colder. In fact, it's almost warmed up a bit now, and that's probably due to conduction from the hot plate back to the cold plate, 16.9. Let's see what happens if we cool the hot plate. Okay, I've now put the Peltier on a heat sink. It's not a huge heat sink, it's just like that, but it is going to suck heat out of the hot side of the Peltier, and I can already feel that the cold side seems like it's getting a lot colder. I haven't used any thermal grease, I've just used a little bit of water to make it stick. Let's see if we can measure the temperature of this. And yes, that's a lot cooler now. 13.5 on the cold side. So you can see that to make a Peltier element work more efficiently, you need to remove the heat that's building up on the hot side as quickly as it's being generated. That then makes the Peltier work more efficiently, sucking even more heat out of the cold side, transferring it to the hot side. That's then taken away, in this case by this heatsink, and the Peltier can produce a cooler, cool side. Okay, let's see if we can get this a little bit cooler. I've now gone to 2.4 volts, so let's see what we've got there. Oh yeah, that's getting cooler still. We're now down to 9 degrees, where the ambient of the mat is about 20. The Peltier element is now 8.5 degrees. Actually, I've only just connected this, of course, so that could go lower still. But yeah, about 8.5 degrees. So more current, more cooling. Right, let's try and get this even cooler. I've now gone to 4.8 volts with this set of 4 ana loops. So let's switch that on and see how cold this Peltier will get. Let's get the temperature measuring device. Where's the laser beam? There it is. Aha, now that's getting really cool. 3. Yeah, under 3 degrees. 2.5. Can't quite get this down to freezing, but it's not far off. Now, I've left this running for a while, and can you see what's happening? Moisture is starting to appear on the surface of the cooler. Water. And that's being condensed out of the air. Moisture in the air hitting this cold surface is now starting to form as water. And that's the principle of a dehumidifier. This cold surface is actually pulling moisture out of the air, and it's collecting here. Now I've just switched the battery pack off. The heatsink is actually getting quite hot. That's getting quite hot. Now what's going to happen now is the heat is going to conduct back through these inactive elements, and the top surface of this is now starting to get quite warm. So of course what will happen is this water will start to now evaporate off that element. And now you can see that because everything's warm, the heatsink's warm, the element is warm on both sides, all the moisture has now evaporated away. Now, in case you're wondering how many amps this is pulling at 5 volts, I've switched to a bench power supply, set that to 5 volts, 5 amp current limit. So let's switch on. And that's actually drawing about 2 amps. That seems to be dropping, which is interesting. That is getting cold. Yeah, that's getting very cold actually. So 4.99 volts, it's in constant voltage, so it hasn't hit the current limit, and the current is 1.7 amps and falling. Interesting that it's falling. See how cold that gets. I think I'll leave that on for a while. Right, that's been running for a little while. The heatsink is really hot, almost to the point where I can't put my hand on it. Moisture is forming on the Peltier again, you can see that. Now I have helped that along a bit by breathing on it, just to get more moisture flow across it so that it condenses down on there. The current has now settled at about 1.6, a little bit more than 1.6 amps. But we're really reaching the limits of this because this heatsink is getting so hot that I'm not efficiently pulling heat out of the hot side of the plate, that's the underside plate, and so I'm not getting the best cooling of the top side. So where can we go from here? Well, how about this? This is a full-on 12 volt 6 amp refrigeration cooling play set, really. The Peltier element is in here. It's behind this sort of foamy thing which acts as a bit of insulation, and it's sandwiched between two heat sinks. This little one here, which is the hot side. Now that has thermally conductive pipes running into this big heat sink, which is all vanes, and two massive fans on there to keep that well and truly cool, to suck all the heat we can out of the hot side of the Peltier. On the other side, the cold side, we've got another little heat sink, and in order to keep airflow running past that cold side so that we can cool that air, there's a little tiny fan on there as well. So this refrigeration cooling device has been sent to me by Banggood. Thanks very much, Banggood. And if you want more information on the arrangement between me and Banggood, see the description. Now you can see that the Peltier element there has been properly thermally greased. You can see the grey thermal grease there and running all around there. So that's been properly thermally greased to this hot side heat sink. The heat is drawn out by these heat pipes into all these vanes and then blown away by the fans. The cold side heatsink actually looks a bit bigger. It's certainly got this more substantial plate, but that's because we haven't got quite so much aggressive moving of air through this thing. So we've only got the smaller fan on there. Airflow on these main fans here is in one direction. So this one is sucking air in and blowing it into the vanes here. This one is sucking that air out of the vanes and blowing it out to the outside. So it's a one direction flow through here. So that should keep this nice and cool. This is all 12 volts. These big fans are 12 volts. The little fan here is also 12 volts there. Let's just focus on that. Yeah, this one is 12 volts, 0.09 amps, and of course the Peltier element, which the wires are here. That of course is also 12 volts if you want to draw the maximum current for maximum cooling. Now to do this device justice, I've gone and got a big 12 volt gel battery out of the shed, so this should have enough grunt to keep the Peltier going and all the fans. And I'm just going to solder on a whole load of these spade terminals onto all the wires so that I can connect whatever I want onto this battery and get this thing generating some real cold. Right, let's attach the Peltier element first. And that's probably going to get hot quite quickly. Let's have a feel of this. Yeah, that's starting to cool down. I'm actually going to take this small fan off for the moment so that we can see this heatsink. These heat pipes are probably going to start getting warm. Yeah, they're getting warm. And yeah, the vane mechanism is starting to warm up as well. So fairly soon I'm going to need the big fans to keep this side cool. So let's plug those in as well now. Right, that's been running for a while. That's extremely cold. In fact, that's got ice on it now. This is not warm at all. The heat pipes are mildly warm. So we're shifting the heat from the hot side very efficiently out of this unit, out of this fan effectively, because the airflow is in one direction. Let's check the temperature of this cold block. Okay, that's -4 degrees, -3 degrees. Oh, -5 degrees if I get this thing properly centered. -6 degrees. So that's very cold. That's forming ice. Let's get in close to that. Right, here's the cold side heatsink, and I mean you can see this is getting pretty frosty. Oh, that's really quite hard to scrape. Oh no, it's not. Yeah, so there's ice building up there. Yeah, plenty of ice. That's immediately melting on my blade because my blade's quite warm. But yeah, quite a lot of ice building up on that heatsink now. Let's leave it a little bit longer. Let's just check how this battery is holding up because I'm not quite sure. That is volts, isn't it? Yeah. When it was last charged. Nah, come on. Okay, 11. I can't get a good connection on this. Why is that? Let's try these bolts. 11.6 volts. That's not too bad. That's holding up okay. Probably having about 6 or 7 amps drawn from it. Right, in order that this unit acts as a dehumidifier, what I'm going to do now is I'm going to cut the power. Now that will mean that the hot side, although it isn't actually very hot, but it'll all warm up, this ice will melt and hopefully create a pool of water underneath the heatsink. So let's undo this and pull those connections off. Both the fans and the Peltier have now been disconnected. Well, that's definitely starting to thaw, and water is dripping down. Oh, there it goes. It's all dripping down onto the table, onto the mat now. So yeah, dehumidification. That moisture got sucked out of the air and is now pooling here, so I could collect it here. I'm dehumidifying the room at about 72 watts. So I suppose if you wanted to build a dehumidifier, you'd have to run this for a while to cool the air around this heatsink so the moisture condenses out of that air and onto the heatsink as ice, and then periodically turn off the Peltier or even reverse the flow, the current flow through it. So this side gets hot, you melt the ice, that drops down into some sort of collection tray, and then you repeat the process. Now I've just discovered this in the box that this unit came in, and it apparently fits over there, and it's a separator to separate the cold side of the unit from the hot side, so that you could attach this cold side onto a plate with an enclosed chamber, and then you could build yourself a little mini fridge. Now let's get some more temperature measurements while this thing is running. The cold side is -4. The hot side is not much more than ambient. Ambient's about 20, I think, yeah, so this is about 25. If I turn these fans off, of course these vanes would start to get really hot. Let's try that. So the Peltier is still attached there. The fans are disconnected. Let's try the cold side again. -5. And the hot side should start to climb up now. Yeah, 28. And that, I would imagine, will climb as I speak and get hotter and hotter. Yeah, that's quite warm. That feels hotter than 28. Okay, it's 30. And that's just going to increasingly get warmer and warmer. Now I've powered up this little fan. It is very tiny, but it's blowing out this side, so it's going to be sucking air in through these vanes and similarly the underside. So it should keep bringing in new air with moisture in it, so that moisture can condense. So hopefully that'll build up the ice a bit quicker. That is running, I think. Yeah, that's running. So I'll leave that for a while and see how much ice I can build up on this heatsink. So while that's running, let's have a look at this item on Banggood's website. Well, it's a 12 volt, 6 amp DIY electronic semiconductor refrigerator radiator cooling equipment. Should say Peltier in there, really. It's currently sitting at $20 or thereabouts. And if we look a bit further down the listing, working current 5 amps, 12 volts. Actually, I ought to measure the current that this is drawing, really. And lots of pictures of the item, and it's set up on a power supply with thermometers, I think, measuring various temperatures. Yeah, they've got about -5 degrees C. I had the same. Well, with this little fan running, that is still running, isn't it? Yeah, I can feel an airflow. What seems to be happening is it's just pulling in lots of moist air, so it's not actually freezing quite as effectively. But for dehumidification, actually that's better because the water's already running off, and you can see there's a big pool of water collecting underneath. So this is dehumidifying quite nicely by sucking warm air across these veins and therefore stopping this moisture from completely freezing, and in fact it's just dropping off the bottom. And if I put a little collection bucket under there, this would be a 72 watt, well 512s, maybe a 60 watt dehumidifier. And you can see this is dripping off the heatsink underneath here quite effectively and creating quite a puddle of water underneath the cold side of this unit. Yeah, that's working well. So there we are, Thermodynamics. For a couple of dollars you can get one of these Peltier heat pumps, stick a 1.5 volt battery on it and shove it in your mouth to feel the cold side and the hot side, or invest a bit more and get a serious 60 watt refrigeration and dehumidification unit going. Oh yeah, that's generating quite a nice bit of water there.
Hey up, lad. That's actually pretty cool.
It is cool, isn't it?
Still think you should get yourself a proper job, though.
This is a proper job. Right, let's watch this ice melt. I've turned all the power off. That's going to start melting pretty soon, I think. Can't really see with it positioned there. Let's move it back where there's no water. Still not running off quite yet. Oh, there it goes. Yeah, I can see ice flow on the heatsink and water starting to drip off the bottom. If I tip that up, there's lots of water. Nice one. And on with the robot kit build. Break out some more pieces on here. Now, some people have been saying about de-spruing these items, other terminology for that as well. Now, what I've always done is just used a knife, a modelling knife, or a scalpel. This is just a modelling knife, just to get a flush cut where you just trim off the sprue like that. This is a pretty blunt knife, so I think that's fairly safe. Right, we need to advance this really, because this is going to take years to build if I don't do a little bit more each time. Well, there we are then. So if you enjoyed this video on Peltier elements, here are another couple of videos you may enjoy. If you want to subscribe to this channel, well, touch my face. And this link here goes through to my other channel, Julian's Reviews. You might want to watch that. If you like this video or disliked it, the like and dislike buttons are down the bottom. Cheerio!